Hello, I am Seema and welcome to part 1 of the chapter Hydrocarbons. I taught you about organic chemistry. I told you that organic chemistry is the study of organic compounds. And organic compounds are the compounds that are present in living organisms, whether living or dead. And then I told you that organic chemistry is not limited to compounds just that are present in the living beings. They could be produced in the laboratory too. Yet, we then gave a new definition of organic compounds and we said these are compounds of carbon and hydrogen. And in addition to carbon and hydrogen, these organic compounds may also consist of nitrogen, halogens, sulfur, phosphorus and oxygen. All of these compounds are hydrocarbons because all organic compounds contain carbon and hydrogen. But for the sake of simplicity, what we do when we teach hydrocarbons, we take only the compounds of carbon and hydrogen and we ignore the other elements because we then classify them into different classes consisting of different elements in the form of different functional groups. And then we study those class of compounds separately. Therefore, just to simplify, when we talk of the chapter hydrocarbons, we are only talking of the compounds of carbon and hydrogen, while all organic compounds are actually hydrocarbons. So having clarified this, let me start with what examples of hydrocarbons would we be interested in. Basically, all living matter consists of hydrocarbons. So anything that is living would consist of compounds of carbon and hydrogen. Or something that died or is in the form of a fossil would still be compounds of carbon and hydrogen. So much so that coal was dead trees which were buried under the earth and they stayed there for years and millions of years, and then they got converted into almost pure carbon and they form coal. And when that gets even purer in the form, it forms diamond. So if you really see, all of those would be kind of organic compounds, although now they are devoid of hydrogen. So when we take the example of hydrocarbons, the most important example that we talk of are fossil fuels. The reason being that the fossil fuels, they form the backbone of a country's economy. Therefore, they are very important. And therefore, when I am going to be giving you, and the textbook also gives you examples of hydrocarbons, we talk of those fossil fuels. So what are the fossil fuels? You have petroleum and coal. These are the fossil fuels which are buried under the crust of the earth, and they have to be drilled out. Like oil has to be drilled out, and for coal you have to build those, you have to drill again, and through caves, you have to coal mines, you mine the coal out. So compounds of carbon and hydrogen would be studied under hydrocarbons. Examples are all living matter, and fossils or dead matter all consist of hydrocarbons. But in the chapter, we are only going to be studying the compounds of carbon and hydrogen. Examples: fossil fuels like you've heard about CNG, that is compressed natural gas, LPG, it is liquefied petroleum gas, LNG is liquefied natural gas. Now, petrol, diesel, kerosene, all of these are actually fractions of petroleum. Petroleum is what you get inside the earth, the liquid that is present inside the earth, and since it is a mixture of thousands of hydrocarbons, you separate them into different fractions. As you drill, the first thing that comes out where there is petroleum is a gas, and that gas is natural gas. So because that gas being lighter, those molecules stay on the top, so when you drill, that is the first thing that comes out. So we call it natural gas, and natural gas is compressed, and therefore we call it compressed natural gas. When you compress it further, the compressed natural gas turns into a liquid, so we call it liquefied natural gas. Similarly, a heavier fraction, natural gas consists mainly of methane, and a heavier methane, propane, but a heavier fraction of it would be a gas that contains butane mainly, which is heavier than the natural gas. That is known as petroleum gas. And if you liquefy that, we call it liquefied petroleum gas, or LPG, which is used in the gas cylinders that are used for domestic cooking. So liquefied petroleum gas, and then heavier than that would be other fractions like petrol, diesel, kerosene, and then you have naphtha, even the candles that you make, the Vaseline that you use, the candle wax, all of those are fractions of petroleum. And all of them act as fuels, and all of them are hydrocarbons. So all these are examples of hydrocarbons. Coal gas is prepared from coal by the destructive distillation of coal, and that is also basically a hydrocarbon, which is mainly the hydrogen also is lost and mainly you're left with just carbon. And the different fractions of petroleum that we get, that is compressed natural gas, liquefied petroleum gas, petrol, diesel, kerosene, all of these are obtained by a process which is known as the fractional distillation of petroleum. As I told you that natural gas is present in the upper strata. When you drill into the earth where there is a reservoir of petroleum, that is where the natural gas is present on top. And then it is compressed to form CNG. LPG is known as liquefied petroleum gas. It is used as a domestic fuel. Whenever you have a fuel that is gaseous in nature, gases would burn completely, because what is burning? Burning is basically the reaction of oxygen with the fuel. So if it is a gas and oxygen is also a gas, the mixing is easy. And since the mixing of the molecules is easy, the reaction is easier. And that is why whenever you have a gaseous fuel, it burns completely. And since it burns completely, it produces less pollution. On the other hand, if you take the heavier fractions, like have you seen a candle? When you blow out the candle, the wick, it kind of, slowly smolders, and the wax that is getting cold, it gives a putrid, a dirty smell. So as the fuel gets heavier and heavier, it starts giving you the smell, also a stronger smell. And in the case of, you would say, how about CNG and LPG, when it leaks, we come to know about it. That is not because the gas itself has smell. There is a smelling compound that has been added to it so that you can detect its leakage for safety reasons. Actually, they do not smell. But the heavier fractions, they have smell, and when you burn them, since they are liquid, the molecules are heavier, the reaction with oxygen is not that ready, therefore they produce more pollution. So which would be the least polluting gas? CNG. Then a little more polluting than that would be LPG, but since both are gases, they are very little polluting. You even have these propane tanks for outdoor grills that we use. And it is advised that you should not use those propane tanks indoors again, because they may cause carbon monoxide poisoning if the doors are closed, especially in cold countries. So kerosene is also used as a domestic fuel, but it produces more pollution. Petrol, diesel, they are used as automobile fuels, and petrol is a lighter fraction and diesel is heavier. Therefore, petrol will produce less pollution, and diesel vehicles produce more pollution. They cause more pollution. Besides these, examples of hydrocarbons would be polymers. For example, polythene, the polythene bags, shopping bags that you use, polypropylene, polystyrene, all these are polymers. The thermocol balls that you use, or the thermocol that you use for packing, that is polystyrene. So all these polymers, which are commonly used, plastics, they are polymers, all of them are hydrocarbons. And the higher hydrocarbons, like have you noticed when you are doing oil painting, you use oil, and what is the oil that you would be using? You'd be using kerosene oil. So kerosene is a very heavy molecule, or not one molecule, it's a mixture of compounds, a heavy fraction of petroleum. So these heavier hydrocarbons or higher hydrocarbons, they are used as solvents for paints, they are used as, then hydrocarbons are used for preparing drugs, they are used as dyes also. So that is why the study of hydrocarbons is very important. Having understood this, now let us come to the basic classification of hydrocarbons. I'll explain the broad classification of hydrocarbons, and then let me just explain it first. Hydrocarbons are classified into three main categories. PG, no. Hydrocarbons are classified into three main categories. Saturated hydrocarbons, unsaturated, she doesn't want me to teach. Saturated hydrocarbons, unsaturated hydrocarbons, and aromatic hydrocarbons. Now, saturated hydrocarbons, saturated, I'm full, my tummy is full, I can't put even one more bite in my mouth, I'm totally saturated. Saturated means full, no more can be added, right? So saturated hydrocarbons are those where no more atoms can be added to the molecule. When will no more atoms be added to a molecule? When all atoms are forming single bonds with other atoms. When they are forming single bonds with other atoms, that is the maximum number of atoms that can be present in a compound. If there is a double bond or a triple bond, that will decrease the number of atoms, because for what is a bond? A bond is a shared pair of electrons. So when you have every electron whose valency has to be satisfied, like carbon has 4 electrons, it needs 4 more electrons to complete its octet. So if every carbon forms 4 single bonds, it means carbon is forming bonds with 4 different atoms. Can you add more atoms to such a compound? No, because carbon is forming 4 different bonds, let us say with hydrogen. It forms methane, right? Carbon has a valency of 4 and hydrogen has a valency of 1. So carbon forms 4 separate bonds with 4 hydrogens. So hydrogen needs only 1 electron to complete its duplet, while carbon needs 4 electrons to complete its octet. If carbon is forming 4 separate bonds, then no more atoms can be added, because carbon has completed its octet and hydrogen, as it is, forms only 1 bond. So any organic compound in which every carbon atom that is there in the compound is forming single bonds, that is known as a saturated hydrocarbon, right? Saturated means no more, it is full, no more atoms can be added, it is forming the maximum number of single bonds. Now, unsaturated on the other hand would be compounds in which more atoms can be added. When would that be? When 2 carbon atoms have multiple bonds. Hydrogen always forms single bonds. Therefore, hydrogen does not show these variations. Hydrogen is only, they're just like dangling things on the sides, hydrogen here, hydrogen there. Wherever there's a loose end, hydrogen is filling it up. But the carbon chain is the one that shows these variations, So, unsaturated hydrocarbons are those where there is a multiple bond between 2 carbon atoms. If there is at least 1 double bond between 2 carbon atoms, it is known as an alkene. And if there is a triple bond between 2 carbon atoms, it is known as an alkyne. So, you have 3 categories of hydrocarbons, you would say, in a way, based on the saturation. The first is alkane, the second is alkene, and the third is alkyne. Alkanes are saturated, alkenes and alkynes are unsaturated hydrocarbons. Then comes a third class of hydrocarbons, which are known as aromatic. Aroma is a nice smell. They have smells, they smell, and that is why we call them aromatic. I like the aroma of this flower. I like the aroma of this perfume. So, they are compounds that have smell, and they have usually aromatic compounds are they have special characteristics. They are ring structures, they are planar structures, they have got alternating double bonds, and they have resonance. We have studied all of this in the previous chapter, so you have a little idea about this. So, aromatic hydrocarbons are sweet smelling. They are also of 2 categories. They may be benzenoid, that is those compounds which have a benzene ring, or they may be non-benzenoid, that is compounds that do not have a benzene ring, yet they are aromatic. Let us now come to the general formulae of these. I will just tell you what the general formulae are in this video, and I'll do a special video, that will be the next video, where I'll explain these general formulae in a little more detail and with a little reasoning of how you can deduce it yourself. Now, alkanes, that is saturated hydrocarbons, they can be of 2 types. That is, they can be open chain or they could be cyclic. An open chain hydrocarbon or a saturated hydrocarbon would be a chain of carbon atoms. For example, this was methane. I'll write CH3, CH2, CH2, CH3. This is a chain that consists of 4 carbon atoms, and it is called butane. But because it has 4 carbon atoms, ane because it is a saturated hydrocarbon. So open chain hydrocarbons have a single chain of carbon atoms, and the hydrogens, of course, are only, their job is to complete the octet of the carbons. If you look at the general formula, if you count here, this is butane C4H10, and methane is also an open chain because it has only 1 carbon, so there is no chain if you really see. You may take the example of ethane. Ethane would be CH3, CH3. So if you look at the number of carbon atoms and hydrogen atoms in alkanes, in methane, what is the formula? There is 1 carbon and 4 hydrogens. So we'll write the general formula, the formula for methane is CH4. The formula for ethane would be C2H6. And the formula for propane, the third compound, would be C3H8. And butane has 4 carbons and 3, 6, 7, 8, 9, 10. C4H10. 10 hydrogens. What do we see here? We see here a pattern, a mathematical relationship between the carbons and the hydrogens. Let us say that the number of carbon atoms in an alkane is N. Number of carbon atoms is represented by the letter N. Whatever is the number of carbon atoms in an open chain hydrocarbon, the number of hydrogens would be related to that. How would it be related? If there are N number of carbon atoms, then hydrogens would be twice of N plus 2. That is N into 2 plus 2 more. So you'll say it is, if this is C4, then twice of 4 is, 4 into 2 is 8, plus 2 will be 10. So butane has a formula of C4H10. Look at this, methane. Methane has 1 carbon and it has, so N is 1. So 1 into 2 is 2, plus 2 is 4. And in methane, what is the formula? CH4. For ethane, the value of N is 2. So 2 into 2 will be 4. 4 plus 2 will be 6. So the formula of ethane will be C2H6. So from this, what do we understand? That the general formula gives you the formula, the general formula for that category of compounds. And you can write the entire homologous series using the general formula. So I just mentioned the general formula here, and I'll do a special video, the next video, where I'll be explaining why are these general formulae like this. For cyclic hydrocarbons, cyclic saturated hydrocarbons, now imagine that this is butane or propane. Propane is C3H8. So how would I write the formula of propane? I would write it as CH3, CH2, CH3, right? If I join this carbon with this carbon, then it will form a ring, right? But in order to make a bond between this carbon and this carbon, I will have to remove 2 hydrogens, which I'll explain tomorrow. But the formula, if you see, when you make a ring where the first carbon and the last carbon join, then both the carbons have satisfied their valency with each other. So they don't need hydrogen to satisfy that 4th valency. That is why 2 hydrogens from both the carbons are removed, and therefore the general formula for cyclic hydrocarbons would be CnH2n. If you're getting confused, don't worry. In the next video, I'm going to take this up again and explain all of it. Right now, just remember that the general formula for open chain hydrocarbons, saturated hydrocarbons, that is alkanes, is CnH2n plus 2. For cyclic alkanes is CnH2n. For alkenes is also CnH2n. And for alkynes, it is CnH2n minus 2. Right? Right now, I know it becomes a little, when you initially study it, you feel why is it so? But when I explain the reason, it would be it would be easy peasy. It will be really easy for you to understand. So now we come to the aromatic hydrocarbons. They are benzenoid, that is hydrocarbons, aromatic hydrocarbons that contain benzene rings, and non-benzenoid like azulene, which does not contain benzene rings. A benzene ring consists of 6 carbon atoms. And here you see this is a 7 carbon ring and this is a 5 carbon ring. It is not a 6 carbon ring. It does not have benzene, therefore it is not a benzenoid aromatic hydrocarbon. So that is all about the introduction and the basic classification of hydrocarbons. With this, I'll wind up today's video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.